In this chapter, we build on the concepts learned in Chapter 3 to also use information from online sources. We need to develop a general understanding of how computers work here to get started. Here are our defined media and computer science objectives for this chapter. Think of the social network movie or social media in general. You are connected with people all over the world via the internet. Networking can be an entire course at certain universities, focusing on how they work and what they do. These are the tasks going on behind the scenes when you complete a task, such as sending an email or loading a website. Do you remember those long cables you used to plug into your computer from a router? Those were called Ethernet cables. Now, nearly everything is wireless. The internet allows you to access any information you may want online. Encodings are how a computer understands and translates information, as we covered in Chapter 1. The internet did exist many years ago, but has evolved into what you see and use today. Protocols, specifically FTP or File Transfer Protocol, is used heavily within the field of web development and design. Now, most prefer using browsers like Safari and Google Chrome, but other browsers did exist. Internet Explorer is not used often, and Netscape no longer exists. A hypertext can be linked or be a hyperlink to transfer you somewhere else on the web. Information is easier to read online when it goes somewhere. If you cannot find the right link once you click, will you trust that website again and go back to it? HTTP is your standard web protocol, but not all websites have the new HTTPS abbreviation, where the S simply stands for secure. Your URL can be a website or a location on your computer, such as an image or video. Here is how a web link and FTP login would be broken down into protocol: domain name, path, and file name. A location on your computer would have C as its protocol. You may need a password to access a subdirectory, or it may have moved. If it moved, you may receive an error message. A client, in this case a browser, retrieves information from a server, in this case wherever a website is stored. With the right commands, you can use programming for web purposes. Here is how you would open a URL in JES. CSV is a file extension for Excel, less common than what you've probably seen, the .xls file extension. You can import a URL and CSV data from online resources when using the right code. With the correct file path, you may access data from a disk too. Here, we are accessing data from the Guardian. We must know the file location for this to work properly. You need some degree of web development skills to know how to upload a file to a server, but with JES, this is made easier for us. Common FTP tools like FileZilla require you to connect to your server with a password and username and then select the files you want to upload. But you can do the same exact thing using the code here, but make sure you import your FTP library class. Anyone using static websites these days is not up to date on current technology related to the field. You can create a website using HTML, CSS, JavaScript, PHP, and many other tools. The browser interprets this input and provides you with a website as output. Transforming information back and forth might require you to create a copy of files to avoid issues in case your files are corrupted or lost. Transforming media can show us how a computer understands. The text becomes numbers because this is how a computer interprets it, as encodings. Try this code to turn sound to text. You can open the numbers, which may represent decibels here, using Excel. We can then graph our numbers to show us a sound wave, as seen here. If your sound file produces too many data points, Excel may not work and may give you the error you see here. A text file can be translated to sound as noted. If there are more data points than Excel can handle, they may be missing when converting back to sound. Try this code to go back to sound via the text file. Here, we are defining exactly what is happening within our while loop. We've done a lot with for loops before, but this is the first time we are seeing a while loop. As we have seen previously, modifying pictures can be a difficult task. Text can in theory be translated into anything. Here, we are creating what could be seen as a printer test page with a visual on slide 45. Break allows us to exit a loop. It's commonly used with if and else statements. Here is the visual of our code from slide 43. It sort of looks like a test from a printer testing the color. Here we see sound as text in many different ways. Everything is an encoding on a computer. They interpret things differently than we do. This array list code will give us a list of sounds. Here, we print out where our sounds are based on our array list. We need to slightly modify our code for pictures. Notice we need our X and Y for pixel location and RGB for our pixel color. Here, our array lists show us the location of our pictures. we can reverse course here as described. In theory, this is true, but with the right code, we should get the right results. Again, encodings are how a computer understands something. We have touched on this multiple times throughout this course. While we do prefer to recycle code when possible, it may not always be possible. We have to keep that in mind. Hiding text in a picture is a common way of transferring information. It is a makeshift encryption, if you will. Always try to write out what you want your program to do first, as we do here. Our function here looks pretty long, but we're finding where to put our text. Here, we've added our text to our image. Can you find it? Decoding is the opposite of encoding. Can we strictly undo something? We can also encode sound instead of just text. Here we find code that lets us do so. And we can also undo or decode sound using code as seen here.